Good afternoon, everyone, and welcome. It's a pleasure to have you with us today for the first session in our two-part series. Today's webinar is titled Getting Advanced Metering Infrastructure Right, Unlocking Market Flexibility and Cybersecurity. My name is Shannon Derejo. This series is based on the report Opportunities for Digitalisation in the South African Energy Sector, commissioned by the South African-German Energy Partnership. The report explores how digitalization is reshaping energy systems and highlights the opportunities that come with the sector's shift towards decentralization, digitalization, and decarbonization. Today, we'll focus specifically on advanced metering infrastructure, or AMI, and how it can be a powerful enabler of market flexibility, stronger consumer engagement, and greater grid reliability. We're looking forward to a dynamic discussion, so thank you for joining us. Before we dive in, just a couple of quick housekeeping notes. You'll see the Q&A section on your screen. Please post your questions in there at any time during the session, and we'll do our best to address them during the discussion. If you'd like to share thoughts, comments, or connect with other attendees, please use the chat function. This session is being recorded and live streamed to YouTube, so if you'd like to revisit today's discussion or share it with your colleagues, you'll be able to do so afterwards. Finally, just a quick note about the presentations. You'll receive the slide decks after the session, so you can sit back and enjoy the discussion. I'll hand over now to Lolile Msimanga, Senior Technical Advisor at the South African-German Energy Partnership, to open the proceedings. Over to you, Lolile.
Thanks, Shannon. Good day, everybody, and thank you for that introduction. I will share my screen and we can get started. One second, just on a full screen. Okay. Can you see my screen?
Yes, we can.
Perfect. Okay, cool. So thanks everybody for joining us today for our first webinar of this series. It is a two-part series that we will be hosting. And it is based off of our most recent report, which was published last week on our website, titled Opportunities for Digitalization in the South African Energy Sector. So I will be just walking us through our agenda for the day, why we are here today, why the report was commissioned, and then I will hand over to our first speaker. So in terms of our agenda, briefly, we'll be going through the background of the report and then going into the transformation of the energy sector in South Africa and the role of advanced metering infrastructure, then starting to go a little bit into the nitty-gritty of the opportunities. So looking into AMI, get right strategies in digital grid, as well as how we leverage cybersecurity to drive digital transformation. You will, as Shannon alluded to, be able to ask questions throughout the webinar, but we do have a dedicated Q&A session towards the end of the webinar, and then we'll have our final closing and wrap up and next steps for these webinars. So without further ado, last week, as I mentioned, we published our report, and you can go ahead and scan the QR code to get your copy of the report, which we have our executive summary as well as our full report available there as well. And in terms of the background of the report and why it was actually commissioned, so a little bit of insights into the energy partnership. So The Secretariat of the South African-Germany Energy Partnership is a bilateral partnership between the German Federal Ministry of Economic Affairs and Energy, as well as the South African Department of Electricity and Energy, and is hosted by the GIZ here in South Africa. And overall, our mandate is to sort of look into how we collaborate between the two countries, South Africa and Germany, in order to advance decarbonization and energy security in both countries. And through this, we have several key topics that we focus on, namely the just energy transition, energy efficiency, flexibility of the energy system, green hydrogen and PTX, as well as energy efficiency, and last but not least, digitalization, which is why we're here today. And through this, we have engaged with several stakeholders around this digitalization topic and what we can do. And out of these discussions, we identified that perhaps we should look into scoping some of these opportunities, what they may look like, and how they can be further integrated into the South African energy transition, and hence the report was then commissioned. The aim of the report was or is to assess the potential of digital technologies to enhance energy security, to support the energy transition to a decarbonized energy system, to explore the role of digitalization in optimizing the energy value chain from generation to end use, and then to unlock socioeconomic benefits, and last but not least, to identify the socioeconomic spin-offs such as job creation and skills development. Because as we all know and have seen, digitalization is having an impact on the socioeconomics of the country as well as globally, more broadly. So for this webinar, we are focusing on 3 out of the 6 topics that are explored in the report. Namely the optimizing of energy grids with AMI solutions, leveraging cybersecurity tools to drive digital transformation, and last, market and demand-driven flexibility in South Africa's energy sector. The other 3 topics will be delved into in the second installment of the webinars. The idea behind having this format and having these discussions with you today is so that we can have an opportunity to distill some of the information that's contained in the report, to deep dive a bit further into some of the opportunities, as well as to demystify some of the topics that you may be unfamiliar with as well. So without further ado, I'd like to introduce our first speaker, Mr. Rashid Khan, who is a program director for energy digitalization and smart infrastructure at Ernst & Young, who is one of the contributors to this report. He has quite an extensive profile. I'll just go through the first little bits of it. So he's a chartered accountant with over 15 years of experience in the South African public and government sector, focusing on energy and utilities, and he specializes in program management, change leadership, and solution architecture. So without further ado, Rashid, I would like to hand over to you.
Thank you, Zolile. I just want to confirm, maybe from the chat, is my sound audible? I noted some of the chats saying that the sound quality wasn't great, but I just want to confirm. Oh, perfect. I see. Thank you, Alexandra. Okay. Let me just share the screen. Okay, so I just want to confirm this. Can everyone see the screen fine?
Yes, we can.
Okay, perfect. So I think just as we commence, we've set up a short poll. I'm sure everyone can see it on the screen, and we've basically asking a few questions. So if all the participants could maybe just indicate and select the relevant box within the poll, and then we'll sort of look at the results of that in a short bit. Okay. And whilst we getting the results of the poll, thank you, Zolile, for that introduction. And thank you for giving us the opportunity today to present to all the attendees here. We are going to we've got some objectives that we're trying to achieve in this webinar, as Zolile has mentioned. And a key part of the objectives is to talk about advanced metering infrastructure solutions and how to get it right the first time, and how to really shape these strategies. So we're going to be looking at that in a whole host of detail today. Okay. We are also going to be talking about some of the opportunities that are emerging out of this new sector, or this new sort of transition that South Africa is going through in terms of the openness of our grid and all the legislation around that. And we're going to be focusing on AMI and what does that mean for this grid. And then we will talk a little bit about some opportunities that we've identified as we were, compiling the report with the team of experts. And to that extent, we've invited some of the technology providers that will be discussing some of the solutions in regard to those opportunities. I think we're now done with the poll. I haven't seen the results of the poll yet, so Shannon, you can maybe just guide me if there's a way. Perfect, I see it. Okay, so the results of the poll, and I don't know if everyone else can see this, but sort of 57%. So a large part of everyone here today are really about just understanding the fundamentals, and that's actually quite interesting. I would have ordinarily thought a lot of the attendees might wanted to unpack a little bit more about grid stability, or et cetera, but I think just understanding the landscape or AMI solutions in general are relatively new globally. So I can understand why everyone is actually selecting that particular answer. And hopefully today we're going to cover off a lot on those fundamentals. Yeah, I think so. Let's get into the detail. Again, I think just maybe from the panelist team, if for any reason during the session my screen stops sharing, just let me know, and then either Yusuf can take over or Shannon can take over. So I thought let's first just zoom out a little bit and reflect what has happened in South Africa, let's say over the last 3 years. And around 3 years ago, we were we were at the height sort of load shedding, and it sort of got worse. At the same time, we also, we were coming out of COVID, and what had happened, there was an interesting change, if you will, in legislation. And that was essentially sort of relaxing or lifting some of the licensing requirements in how, private generators could connect to the energy grid or the electricity grid. Okay. And since then, over the last 2 years, there's been many reforms and many legislation that has been passed that has essentially now created a far more open grid. And I know we're still at the early stages. Next year, there is definitely what we as the country can look forward to is the launch of the new market, the electricity market. And there's a lot of work that NTCSA, which is the National Transmission Company of South Africa, there's a lot of work that's being done around that launch. Similarly, there are reforms that are driven by the presidency under NECOM, which is the Energy Crisis Committee, that has essentially been created in driving the reforms of having a more open grid, a more open market, and actually assisting in solving the load shedding problem. And then there's obviously the distributors, such as Eskom and many of the municipalities that have been focused in bringing out policies and processes in better connecting renewable energy to the grid. So what you see in front of you is kind of, what South Africa is going through at the moment is the big drive in decarbonizing, as well as opening this grid, has changed sort of the way our energy value chain looks. Traditionally we had a monopoly, and in that monopoly, Eskom typically owned the value chain from generation, transmission, distribution. But now that's changing. Now what we're looking at potentially in the future, and this is not just for South Africa, but globally we see it in many countries, that many countries are looking to dispatch and making sure that base power is there, and it's connecting into a grid where the various off-takers in the future will be different. And will have different needs and different requirements to comply to various green legislation or decarbonizing targets or sustainability targets. So essentially, we are really speeding, in South Africa, we are speeding towards a new energy system, right? And in this system, your municipalities, your distributors, your distributing system operators in the future, they will be critical players, and essentially they will need to understand how energy flows in both directions. Therefore, in order to enable this transition and maintain network safety, stability, and quality, smart metering is becoming a key underlying technology to assist these various stakeholders in really understanding the grid and what's happening on the grid. So therefore, when one talks about smart metering, we've always got to understand that smart metering is but a component within what we call advanced metering infrastructure solutions. And AMI is really the topic that we're going to be unpacking. Smart meter is but a single component in a much larger value chain, or in a much larger solution. And essentially, when we talk about an AMI program, what we're talking about is an integrated system of smart meters, communication networks, data systems, etc., that essentially enables, the two-way communication between utilities and customers. And what's important, from the onset in these programs is that there are some key questions in every one of these programs that typically need to be answered, amongst others. That's typically, what are the priorities we're aiming to achieve with an AMI program? What type of intelligent information exchange are we hoping to be defined? What is the common AMI technology? How are we going to engage and educate customers? And how are we going to plan how we will install the meters through the various geographies? So these are just some of the questions that we've learned over time that are important from the get-go to ask. And part of running a successful program is to firstly ensure that there is a seamless deployment of those meters. It's not just about the systems and the technology, but it's really about ensuring how we deploy that in a particular area or site. It's also about ensuring that there's a well-established communication network to ensure that the meter can talk to the system. And one of the mistakes that we've seen in many programs is that there's a very large focus in ensuring you buy the correct meter that complies to the correct standards, it's at the correct price, etc., etc. But what we found over the last decade is that, the standards and how they get approved and how the meters are calibrated and where they're tested, that's quite advanced in South Africa. There is quite a large availability of different meter types and meter providers that provide those meter types. But often the one focus that a lot of organizations and clients and utilities and municipalities, what we find that when we're dealing with the project teams, that there's a lack of understanding in that communications network, and it's the backbone to an AMI program. So having a well-established network and understanding how to do that is an essential. And then what's also very critical is that one of the components of the solution is what we call a meter data management system. And this is a very important component that helps you validate data and understand its correctness, etc., etc. So having and ensuring that we've got, well-specced, scalable meter data management systems that's based on modern data frameworks becomes very important. And then one of the key essentials is just to make sure we've got a well-executed communications plan. So these are just some of the initial highlights we're sharing around what is an AMI program, some of the key questions that we typically ask, and some of the essentials that are a part of an AMI program. Now, given this change that we talked about within our energy value chain and how we are going to see more renewable energy penetration within the grid, how we're going to see the value, the whole value change over the next decade, I think it's important to talk about the role of AMI in the future. And I thought the best way to do this is through just talking about some of the use cases, the user stories, and the impact thereof. Now, traditionally, many municipalities and as well as many utilities around the world, and particularly in South Africa, we see this, that a big drive of rolling out smart metering solutions and AMI solutions is really around revenue optimization and to reduce losses, right? And I think many of us are familiar. Often I pick up various articles of municipalities that are in debt with Eskom, or that are having significant losses, and almost coupled to the article is some project or program around implementing smart meters. But what's important to understand is that going forward, that there are other very important use cases and user stories that the country needs to think about and take advantage of. And AMI becomes very critical in this. One of them is the use case around ensuring that within our country, all our large power users, the ESCOM points of deliveries, the various statistical meters that are at key substation points, etc., have such smart metering and AMI technology. And this is one of the key opportunities that we will be discussing later. And we also have from one of the technology providers, which is Camstrip, they will be talking about this particular use case. So we will not focus in a whole host of detail on this particular use case. Then other use cases that we will be seeing in the future will be around demand response and load management, and this is to ensure that distributors and energy distributors in the future have mechanisms to manage high demand periods. And I'll also cite some, articles of late over the last year. You'll see that there's various pilots being run by ESCOM and some of the municipalities around demand response. And the key enabling technology for those programs are smart meters and AMI solutions. Okay. In addition to that, AMI solutions, can be used for grid stability. It can be used for distributed energy resource monitoring. So just looking at the various integrations of those solar plants, those wind plants, etc. It gives us the kind of visibility. And then one of the key use cases that we're going to see in the future, which I think it will be a very important initiative for large utilities such as ESCOM, that will be important for your large metro municipalities, or even for property owners that manage many properties and sites through South Africa. We've got a very large private metering sector within South Africa. Control rooms that essentially are used and act as what we call smart meter operation centers, or you'll see the term a SMOC. AMI becomes a very important component within the smart meter operation centers, because essentially what they do is they aggregate all the data from the meters and they drive certain decisions. They look at various analytical dashboards and they help drive processes. And these are becoming very important, not just for electricity and energy programs, but also within the water sector. Within the water sector, we're also seeing lots of issues within the country, and a big part of this is around losses. And those losses, the one key way to understand those losses and to mitigate them is to really digitize the water reticulation networks and to understand what's coming in versus what's going out. On a manual system, it's a very difficult thing to do. Other use cases that we see on the screen, and I'm not going to go through everything, is around dynamic tariff innovation that we will see in the future, and AMI is key to that. It's around data aggregators within the country. It will be around what we call market enablement for flexible products and energy trading. AMI technology is going to be key to this. And also, as part of today's session, we will have Frank, that I will introduce later, that is from Meridian Economics, and he will be talking about some of the innovative solutions on token wheeling and how that platform will enable use case 10, as well as how that is dependent on AMI technology as well. So you can see the point to make here is that the role of AMI in the future, anyone that today in the attendees that is from a large distributor, that is from a large property company, is from a large municipality, etc., etc. You know, you've got to understand that the way you're going to use smart metering or AMI will be a little bit different in the future. So I hope that comes across. And I hope you can, digest these use cases and user stories. And as part of any strategy that you set up in the future, remember that to consider these. It's not just about optimizing revenue or understanding your losses, but AMI can be used for much more. In addition to that, globally, some of the projects that we've implemented and have worked on, in various countries, you'll find that these AMI programs, there has been various programs run in various other countries. In fact, when you look at the US, the UK, and the Middle East, you'll find that they are far advanced in terms of quantity in rolling out smart metering solutions and AMI programs. What we've learned in just studying some of these programs is that a lot of these programs have had various cost overruns, had various delays, etc., etc. And we've carefully studied these programs, amongst others, to understand what would be the best way and how best and how practical should we implement certain strategies and frameworks to kind of de-risk AMI programs. And I think that's sort of the message that I'm going to get through over the next 30 or 40 minutes. With that said, I'm not going to take or go through any examples now, but later on, Mohsin from a company or one of the technology providers called Camstrip might touch on some real practical examples and talk to some of those projects. Now, the inherent challenges when rolling out an AMI program, and as I mentioned earlier, is there's such a focus around the smart meter, or there's such a focus around just the technology components. But what one needs to understand is that, historically, many municipalities or many customers in the private sector have had manual or mechanical metering, right? And you typically have read that meter once a month or once in 2 months, and have estimated that meter for in cases where you cannot access the meter at the client's property. But with smart metering, that obviously changes, right? Now you are reading the meter at least once a day, in many instances up to an hour, and what that means is that the volume of data that you have is enormous. And not just that, it's not just about how much of electricity I consume, but there's a whole host of data that comes out of the meter in terms of events and alerts, etc., etc. And what that means within this value chain is that, firstly, from a customer perspective, you immediately find that there's a lot of touch points with your customers, right? There's normally lots of context, especially when you start rolling out your AMI program. Typically, customers experience what we call bill shock, or they experience a sudden increase because historically their meters weren't well calibrated or have been under recording, or etc. And now suddenly there's suddenly an increase in billing. Similarly, within the value chain, any utility such as Eskom or any distributor like one of the municipalities, there's such a change to the way your business operates, and understanding that change management and how to handle that impact on operation changes. New capabilities is needed within these organizations to be able to, from day one, when the smart meter or the AMI program is launched or implemented, one needs to have capabilities, some technical capabilities on understanding, a digital meter, a communication network, a meter data management system. So the point to make here is that an AMI program is not just an infrastructure rollout of meters, but basically it becomes a large transformational program where you are digitizing operations. So everything around change management, having the correct project management office in place is important, because you are simultaneously managing an infrastructure program, a digital program, and a transformation program all at the same time. And when the first meter goes into the ground, operations go live. There's no handover period. It's not like you're building a bridge and you've got to hand over that, at completion. But actually, you're rolling a project and operations at the same time. So these are some of the challenges that one needs to understand when deploying an AMI program, and its transformational nature. Some of the lessons that we've learned over the years is that there's really, in many of the projects, we find that there's a lack of a focus on driving a business-led solution. And I think this is one of the big problems we have in the industry at the moment. Often we find many technology providers are holding the hands of clients and utilities and municipalities, and essentially trying to sell a piece of technology. But what is important is that organizations, utilities, business, municipalities, property owners, you really need to sit down and understand, how are you as the business going to architect this solution, and what are your requirements? There's also a big problem in the type of business advisors that we see. A lot of clients are employing business advisors that don't have the depth and don't really understand the real complex nature to mobilize and coordinate and operate such solutions. Other lessons that we've learned is that always look to get a solution agnostic design. Don't lock yourself into a single solution or a single provider. This must be a key principle when you are developing your strategies and your procurement strategies. Be agnostic and be careful of that. If you select the wrong meter and the wrong modem, for the next decade, you can potentially be locked into a service provider and you won't have the flexibility. And that's not great for any distributor out there or utility. There are lots of issues and changes that are going to be required within IT systems. And, one of the problems I see in many municipalities is that your current technology stacks are quite complex. So when you are introducing a change, these governance processes for the changes are often taking many months. So your upfront planning, in advance planning, becomes very important, because you can't just come with the new a solution of this scale that's going to bring so much of change and think that the IT departments are going to just understand and accept the solution. So you've got to do a lot of planning around that. There are other lessons that we've learned around ensuring you've got the correct processes from day one, the correct people. One of the big global issues that we have, it's not just in South Africa, but there's generally a lack of experts that fully understand this value chain end to end, and that see that holistic picture. And I think a lot of work will need to be done in the coming years at university level in really helping build, that pipeline of expertise that can be deployed. Many municipalities that I work in and go to, and very large municipalities have a lot of skills that are not there when it comes to the people side and how to manage such programs and to continuously operate. And what that means is that that often you're then at the mercy of service providers, et cetera, et cetera. So these are just some of the lessons. Obviously, in the interest of time, we are not going to be able to go through all of this, but you'll definitely find a lot of this content in the much larger report that we've put up in the screen at the start. So I think we're going to move on to the next. We just want to end off with a bit of a poll, and we want to understand, based on your understanding of the country, and if you've been involved in any rollout of an AMI program, what was your biggest challenge, or what do you see as the biggest challenge in the country? So if everyone can maybe just again answer the poll, and let's analyze and understand what is everyone saying. I'll just give it a minute, and then we'll look for the results. Again, while we wait for these results, I'll Shannon or Yusuf, if again anything goes wrong with the screen or my audio, just let me know. But I'm proceeding with the hope that everything's fine.
Will do. I'm just about to end the poll in 2 seconds. Thanks to everyone for voting. And here are the results. You should be able to see those results.
Yes, thank you. And I've got them up on the screen for everyone. So as you can see, a lot of the attendees here are saying, at least half of the attendees are saying the biggest challenges is around business readiness and change management, and I agree with that. The first 4 around AMI strategy, funding, procurement, technical. There's a lot of work actually underway by the ESCOM team, some of the municipalities, and actually by the National Energy Crisis Committee, NECOM, in developing strategies for the country around AMI. Funding is definitely a challenge, but there's lots of innovative ways I think we are not exploring correctly. Procurement, technical, always a challenge. Everywhere it's a challenge, right? And we can talk a little bit about that. But I think the complex specifications, governance, in South Africa, our big problem, not problem, but we need a lot of controls around open tenders and how they run, et cetera. But often what that means is that, and I've personally, and I've seen this, we've often seen, the way procurement processes are run. They often don't necessarily appoint the correct provider, but it appoints the on paper correct provider, which obviously in the future might not be the best. But there's lots of sort of activities within your SCM or your supply chain processes that, doesn't necessarily consider what the technology guys want or what the business want, but you've actually got to comply to the PFMA and the MFMFA. So having a deep understanding of those processes become very important into the future, especially for the business teams. But yeah, so these I think at the moment in the country are our major challenges and some of the solutions. We definitely need a country strategy for AMI. We've got ESCOM, we've got many municipalities, we've got the private sector that does private metering, and a clear strategy is needed, right? Funding, these programs. If you, in my estimates, high level, if every meter in the country has to become smart, the country needs about 100 billion rand to do that. So lots of money is needed for these types of programs. So we've got to just carefully look at how they are done, to which customer segments, etc., etc. Procurement, we need to just nationally streamline this better. To that effect, you'll already see some national tenders around AMI, mainly being the RT29 from Treasury, etc., etc. But a good think through on how to do this in the future, I think, will be important. But the teams from Treasury and Senedi, I know, are currently looking at this. And then technically, yes, there are lots of challenges around that. And part of all of your planning has to just carefully build out what we call a solution architecture that's really understands how to integrate it back into your IT environments. So we've really talked in detail around the challenges, the lessons learned, and you've seen that we've really, the focus has been around this full value chain. So the question is, how do we get this right? Okay. And I want to share with everyone today, based on some of the projects that we've run here in South Africa, as well as globally, within various companies and teams, I'm hoping to share with everyone today what is it that is needed to be done within your organizations to get it right the first time. So for me, there's typically 3 focus areas that you've got to think about in building that strategy. The first is, how are we going to mobilize and run the program? Okay, setting up the program from get-go correctly is very, very important. And that talks to your strategy and your business case. If you don't have a strategy and a business case, almost certainly you're going to get this wrong. And later on, when you don't see any benefits, and we've seen a few programs in the country that doesn't have any benefits, one can always go back and see that those strategies and those business cases and the benefits planning behind that was not done correctly at the start. You've got to set up your PMO from day one and establish the plan on what you're going to be doing over the next couple of weeks, months, and years, right? Then you've got to correctly design that AMI solution, not just the technical design, but the business design. How will your operating model of the business look in the future? And then you've got to make sure you onboard those vendors that are required to give you that technical and the business solution. You onboard them correctly, following the correct governance processes, making sure you select the correct vendors that can get the job done, etc., etc. Then the second get right is around making sure you can deploy that and manage that AMI solution, right? And this talks about your installers, the field delivery, how to ensure you install the meter the first time correctly, following the correct standards. A lot of projects don't understand that there's certain NRS standards you've got to follow in commissioning a meter. There's certain checks that you've got to do from day one, and understanding that the minute you put that meter in the ground, immediately it goes into operations. So you've got to make sure that when you create your deployment and installation plans, you are doing advanced planning around all the procedures, as well as processes, and establishing those operational tools and centers from day one. Okay. And then the third thing is making sure that you can extract maximum value out of that AMI data. Leveraging that data becomes very, very important in driving operational and customer benefits. And as I mentioned before, it's starting by creating the right use cases and how you are prioritizing them. It's not just about revenue optimization or reducing losses, but it's looking in the future where your utility is going. But that for me is when I start. Normally, I start here and I ask myself, how am I going to get 1, 2, and 3 right the first time? Now, in order to get that right the first time, what we've developed on some of our programs is what we call a smart metering framework. And I'm hoping today to unpack this particular framework. I don't think I'm going to have enough time to do that. Ordinarily, when I unpack the framework, it's over a week of various sessions with clients. But I'm going to try my best to just touch on some of the items. But within this framework, we've got various, if you'd like, pillars. And these pillars look at strategy, program management, the solution, how we do the rollout, the procurement, customer strategy, the business engagement, and what we call the intelligence and the analytics beyond the meter. And the value of this framework is that typically it's based on a set of methodologies, tools that allow us to, quickly de-risk an AMI program. We've thought about all the insights and lessons that we've learned and we've incorporated into the framework. And it really helps us guide such a program from cradle to grave. And it provides those guardrails. So in your strategies, when you're establishing this strategy, you've got to keep this type of framework, because behind these frameworks are typically activities, sub-activities that people need to do, that technology need to drive, and having such a framework and having such a thought process becomes very important. Now, within the framework, I mentioned some of these pillars around strategy, and essentially strategy and business case and funding is making sure that we build upfront the roadmaps and we understand the business case and all the value drivers. It's around the next pillar is around program control and value management. So it's making sure you appoint the correct team, that can help identify the risks, scope it, look at the complexities, etc., etc. Then it's about making sure, in terms of the smart solution, it's about looking at the business and the technical architecture. And I really implore many of the attendees here that run organizations, whether you're in the public or the private sector, to really explore pilots. The best way, theoretically you can do a lot of thinking and planning, but the best way is get a pilot project going, understand how the solutions work, understand the technology. There's so much of choices these days. And, a wrong choice, really will impact you into the future. Don't forget about the customer. That's why that's an important customer pillar for us. Often, we forget about the customer, and I always like giving a good example. And I, again, implore the attendees, there's a company based in the UK, they call Octopus Energy. Go to their website, Octopus Energy in the UK, and read about their journey. And, they started about 5-6 years ago in the UK, and they went from managing one customer to managing more than 5 million customers. And the way they did that was they had two focuses as the organization. They focused on technology and they focused on the customer. And therefore, really, when one comes up with strategies, don't forget about these two critical components. It's worked well for many organizations globally. I'm not going to go through the rest of the pillars, but they're about procurement and business engagement. But you can sort of understand now, when one deploys such AMI programs, getting this framework in place from day one, and the thinking and all the activities become important. This is an example of how we take the framework, right, and we break it down into various phases and work streams. So this framework and this implementation methodology that you've seen, we've successfully deployed it at a few projects here in South Africa and globally. And so the journey that I typically follow on the AMI programs that I've run with some of the teams, we break up the phases into a concept and a due diligence and feasibility, a solution orchestration, a pilot deployment of the solution, a mass deployment, and sort of an operations and a maintenance phase. And within these phases, those framework pillars, we bring them down to work streams and we run them over the various phases. So what's very important is to understand how to deploy the framework within your organization, and to essentially, always align your various stakeholders and process owners, etc. Look, in the interest of time, I'll talk about one or two of the pillars in detail as best as I can. I know I've got a hard stop in about 15 or 20 minutes, but again, the team will guide me on that. So one of the important pillars is around strategic, setting up the business case from day one. And this is really about making sure that you quite clear on where you're going as your organization, back to those use cases, how you're engaging your senior stakeholders, right? A lot of time internally, you've got to sell the project correctly. It's about understanding your financing options and models. It's about understanding the business case. And it's really about envisioning the future operating model of the organization, because this, as I mentioned, is a transformation program. Now, again, but another framework, and what I typically apply, I sit in sessions with teams, and I think through what is the vision, what is the ambition that I'm trying to achieve. I then take that vision and I break it into various business drivers, and to those business drivers will be benefits. What am I trying to achieve with the program? Is it loss reduction? Is it customer happiness? Is it revenue enhancement, etc., etc.? So I've got this at the back of my mind. Then I spend a lot of time with the operational teams, really coming up with the business requirements. What are we trying to achieve? Do we want a customer app? Do we want an operations center? Do we want to disconnect in real time? All of these requirements are really looked at very carefully. And then essentially we come up with a set of functional requirements, right? And that helps me to decide what is the technology that I need. So what I don't do is start here with the technology provider that guides me and says, you need this, and here's my meter, or here's my system, because then I'm going down the wrong path. But actually, I sit internally with the business teams and I figure out what is it we want to achieve. Then I go out and figure out what is the technology that I need and how will I procure that. And then finally, I make sure that the business is ready it's got the correct operating model, and right up front in the strategy, we are already thinking about what we call the target operating model. And an operating model is basically just the people, the processes, the systems, how all of that will work. We try to understand how can we gear up that team to make sure when meter number one is in the ground, they are ready for that. Important questions we ask ourselves is, what type of metering system architecture are we going to deploy? Is it revenue-based, operational-based, hybrid? Are we going to put a lot of distributed energy within the grid? How smart do we want the solution to be? What type of communications technology do we need? And this is very important to understand. You've got to understand what are your options. You've got to work with your mobile network providers, such as Vodacom and MTN and Telkom and Cell C and Sigfox, and understand what type of solution is needed. So these are many of the questions that upfront, when you are setting up your strategy, you've already got to start thinking through. You've also got to think about, how am I going to fund this? How will we procure this? How will we enable the business? How are we going to effect change? How will we educate the business? So you can see there's a lot of work that need to be done upfront, before one actually goes out and procures a particular solution. There's also different delivery models. You can self-finance, you can put this off balance sheet. And we've got some good examples in South Africa in some of the municipalities on how they've done an off-balance sheet transaction, where they've set up special purpose vehicles, where they've implemented escrow solutions and used the AMI solution to drive an innovative financing type program. But I'm running out of time, so I'm not going to go through all of the detail. I think a big focus will probably be to talk about some of the opportunities around, the report, and in doing this research, what we've identified. But clearly, you can see, the topic about getting AMI right is quite extensive. An hour or two, it doesn't do justice, but just to touch on some aspects are important. So I am going to move through some of the slides and skip some of the slides, just in the interest of time. Okay. I thought I'd just spend some time here. We've been talking a lot, but understand that behind even the strategy, there's a technical solution, and they can become quite complex. And whether you're the enterprise, or you're running the network, or you're customer facing, again, there's lots of questions that one's got to think through. What type of meter data management system? What type of analytics platform? What are my data requirements? How will I interact with my customers? So again, my message here is, really do your homework, do your research, get the relevant expertise that you need in to really advise you, and give you that independent advice. I think that becomes very important. These are examples of some high-level architectures that we've rolled out in setting up metering and setting up smart metering operation centers. And we'll talk a little bit about that in the opportunities. This is just one example. I know lots of the municipalities use SAP, City of Joburg, City of Tshwane, City of Cape Town, all use SAP products, and a lot of them are having to move into the cloud. So this is an example of how you architect a solution. So when we talk about a solution architecture, at least this sort of, hopefully this resonates with the attendees. But what you can see is you've got to also deeply understand your technology providers and how you can put their components together in order to achieve those use cases and set up those operation centers. It is not that straightforward. Yeah. again, just on data, smart meters and data, and we were talking about this, it's not just about how much of kilowatt hours I use, but meters have alerts on outage, voltage, when someone tempers. It's got data on billing, load profile, power quality. It's got various functions to connect and disconnect, etc. And these are some of the data that we are seeing in the systems. You can see it's a whole lot more than previously what was available to utility providers. And Mohsin later will be talking about some of these data points and how they come into analytical systems and how they can be used. But I think what's important is to understand that you've got to learn to harness this data into the future. And so right now, those data points, you will use them for certain grid applications, right? But in the future and beyond, you're going to be able to use all of this data from these AMI solutions in a whole lot more differently than you've anticipated, So if I had to map this to a now and next grid application level, this is kind of how it will look in the future. These data elements are going to be supporting outage management, active network management, how we model and forecast energy data, asset management. All of the data that comes from these smart meters and AMI programs are going to really enable these type of grid applications into the future. I am out of time, so I'm going to have to get into some of the opportunities, because I think that was one of the key items, and we're going to talk a little bit about these opportunities. So one of the opportunities and the use cases that I mentioned up front was we as the country, South Africa Inc. We've got to understand that our meters are, especially our meters for the large power users, they are kind of spread between Eskom, which looks after about 30 to 40,000 of the large power users in the country, city of Ekurhuleni, city of Tshwane, etc. So a combination of these sort of municipalities and the large power users they look after equate to about, I'd say, 125 to 150,000 key metering points in the country. Okay. And the idea behind this opportunity says that if we have a very targeted program in the country that focuses on making sure every large power user in the country has a smart meter and potentially a smart breaker, how that's possible from a safety perspective. And I'm sure there's technology that's available. But if one does that, potentially we are going to be able to digitize probably 70 to 80% of the grid very quickly in the country. And installing 150,000 meters is small in comparison when installing 10 million meters throughout the whole country. And the benefits versus the costs of that is, it's really, it's an insane amount of benefits that the country will get. So I think one of the key things that the country and the various organizations, whether it be Treasury or how Eskom and the municipalities collaborate, or whether it be Senedi or whoever it may be, and how donor funding partners come to the country, there should genuinely be some sort of focus on an opportunity like this. Because in my view, this is what I call a low-hanging fruit. And there's definitely steps to enable the opportunity. I think the biggest hurdle will be how the municipalities and Eskom work on such a program of this sort, given, their respective procurement processes as well as their IT governance processes. But we definitely need to look and think through this as a country. This, for me, is a major opportunity that I think we are missing. And I'm hoping when we do the introductions after 3:30 to Mohsin from Camstrip, he can explain a little bit about what this could mean for the country and what this could mean in the back-end analytical systems. Okay, but some of the steps I've looked at is around a national tender, which I think partially exists, but needs to be just looked at carefully. It's about making sure that the buy-in, between, these sort of organizations and a few others, are well understood. It's about kind of leveraging the strategy that the NECOM team are busy with. I think these are important steps that are there that one can use to enable the opportunity. The opportunities of doing this, and I talked about the benefits, are, as I said, in my view, very, very large. A lot of this article, news articles and speak of today is about how we're going to integrate distributed energy resources, how we're going to do the complex reconciliations when we do that, how we're going to be proactive in load management, how we're going to get more accurate billing within the country. I think that a lot of this will be enabled by such an opportunity. So really, I think the opportunities that I see are definitely immense. And as I mentioned, I think the complexity is just how we do this and how we coordinate amongst the stakeholders. But if I had to cost out an opportunity like this, in my view, this would cost the country 2 billion. But I comfortably think that the benefits on such a program would be north of 10 billion rand to the country, and I'm sure the financial modelers can play around with the numbers, but I'm sure these are some of the benefits we're going to see. So really, I hope someone is listening out there at very senior levels that can really think about this opportunity. I think we are, as a country, unfortunately, if we are not going to be focused on such an opportunity, then we're going to lose out. Maybe before we take any questions or deal with any questions online, I think the second important opportunity that the report talks about, it talks about more of a centralized AMI analytics platform, right? And what this is for the country, and maybe just let me explain this a little bit more, right? Is that, to recap the metering data system, the ecosystem, there are smart meters, there are networks that need to be monitored, the cellular networks and radio networks, etc. There are head-end systems that help you collect data from those meters and translate the information from those meters into a language that other systems can understand. There are meter data management check the data. They are a very critical component. The head-end and the MDM are the sort of the engine in an AMI technology program. There are then obviously your billing and your customer relationship management programs. There's the various customer portals. And then there are asset management systems. There are in-field systems. There are external sources, right? This is the ecosystem that we're dealing with. And within there are various pieces of data, as I mentioned before. There's load profiles, there's meter events, there's signal strength, there's transaction logs, there's validation logs, there are customer profiles, there's customer data, etc., etc. So I think the message here, the challenge here that organizations have is that there needs to almost be a single source of truth and an aggregated view of all of that data into a particular platform, so that one can really understand, what are the challenges, etc., etc. And at the moment, when I look through many of the clients that we deal with, when I look at, even if they have AMI programs in place, a lot of the challenges that I see is that there's a lot of heavy lifting at that system level in manual tasks and doing manual Excels and working in sort of manual databases that are not talking to one another. And they're sitting with this richness of information, right? And we need a way to get all of that information into a single place or platform or room, or and this is kind of starts building and helping you to understand what a smart meter operation center does. It essentially helps us to take the various pieces of data, however we may integrate that, and move that into a way where we can continuously monitor all of those systems through various KPIs, right? So we need to move away from all the significant manual effort. Even though these systems are automated, the way we are working in these systems are quite manual. And we need to move the focus into a more KPI-driven type platform that helps us to kind of respond a whole lot more proactively to issues and customer complaints, etc., etc. And that's a challenge. Therefore, a SMOC, or a smart meter operation center, becomes a very critical capability that's needed. And in the country, Eskom needs this capability. Your large municipalities, they need this capability. Your smaller municipalities jointly might need to invest in something like this. Your entities, such as a Transnet or a PRASA or a Growth Point or whoever that may be, right? That owns lots of properties with private metering. You need these kind of capabilities that helps you understand your energy losses, whether your rands and cents are balancing, how you're going to enable new use cases in the country, such as third-party energy wheeling. And Frank will talk a little bit about third-party energy wheeling. So that becomes an important consideration. So essentially, a SMOC, or a smart meter operation center, or the platform, is a combination of people, technology, etc. And it really helps us to aggregate data a certain way, do data analysis a certain way, really have a single view of a meter. If one can understand a meter, the cover came off, it was disconnected, the consumption suddenly stopped, it then started again, the cover was put on, and suddenly the customer profile has changed. You can use quite an advanced algorithm to quickly identify that is a potential temper that needs to be investigated, and I need to send proactively the field teams out there to go do the audit or the investigation and avoid the losses. And that's why sometimes you often hear, as an example, municipalities investing in smart metering programs. They've installed the smart meters, but no benefit comes out of that because you have this lack of proactive monitoring. The smart meter does not prevent a tamper or theft. All it does is it helps you more definitively identify that so that you can deploy the resources to correct it, if that makes sense. So a more centralized, taking the concept of a smart meter operation center, if one had all these large power users, and however the technical solution could work, I've got some ideas on that, but that's quite technical and quite detailed. But if we centralize all of the data a certain way, complying, to obviously the various organizations and rules or whatever they may be. If we find a way to sort of bring all of this into a national platform, it will really benefit the country. You know, we will have, you know, this use cases, and again, Frank later will talk about third-party energy wheeling, which is something you're going to see in the country. You're going to see it pick up quite a bit, my estimations, and provided we remove certain barriers. And the way we buy and sell energy in the future in the country, we are going to, various organizations are going to need platforms to be able to understand how to enable such deals, to reconcile such deals, etc., etc. So you're having this platform and investing in such a platform as a country, I think, is going to be important, you know. And remember, keep that at the back of your mind, that if every LPU plus the critical metering points are fully digitized and on an AMI program, it will account for more than 60 to 70% of digitizing the grid, right? So I think that's sort of the idea in terms of opportunity number 2, right? I think I'm almost out of time. We're about to go into a break, but I think what we are going to look forward to in terms of after the break at around 3:30 is we're going to introduce firstly, I'll do sort of the introductions now, but we're going to have Mohsin from a technology provider called Camstrip. Camstrip is a technology metering solutions provider for electricity, water, that is based in Europe, that's based in Denmark. And Mohsin is the technical solution and sales lead from Camstrip, and he will be talking about some of the technology and the lessons that they've learned that relates to what we've been talking to. Then after Mohsin, he will hand over to Frank. Frank is from a company called Meridian Economics. Meridian Economics is well known. You know, in the past, they've supported the presidency in various economic type work, modeling type work, etc. And Frank will be discussing what we call a market flexibility type solution called token wheeling that enables third-party energy wheeling in South Africa. In South Africa, as you know, there's some barriers on having a full 100% market opened for third-party wheeling. And so lots of companies are looking at innovative ways to enable the reconciliation, and AMI will be key behind these solutions. So Frank, after the break, will really be talking about token wheeling. So with that said, I hope everyone has found this informative. I do know there's been a lot of questions asked on the chat. So as we proceed with the rest of the presentation, I'm going to try and answer many of those questions. I think if we start taking live questions, we will run out of the allotted time. But therefore, I will opt to rather do this in the chat box. And it's also just to note that after Frank is done, we will most likely hand over to a cybersecurity team that is represented by Pramod from the Ernst & Young Mauritius team, and Kalyan from the EY Ernst & Young Mauritius team. And they're really going to talk about cyber and the link between OT and IT. And it's often a forgotten topic, a very forgotten subject, a very forgotten topic, but there's some real risks. And Pramod and Kalyan are going to be talking about that. So with that said, I think it's time now for the break up until 3:30. and we will reconvene at in the next 8 minutes. So yeah, Shannon, can I sort of hand back to you? Is there anything that I might be missing, or anything that you wanted to add before we go on break?
No, that's it. We will just be sharing a short slide so that people will know that we'll be back in 5 minutes. So don't leave your seats. We'll see you all in 5 to 10 minutes. Thank you. Mohsin, we're ready for you. You are on mute if you are speaking.
Hi, Shannon, can you hear me?
Yes, we can hear you, and I can see your screen as well.
Excellent. All right. Good afternoon, everybody. As Rashid mentioned, my name is Mohsin. I look after the sales and some of the solutions that we sell in Kamstrup, focused on Africa. I know the time is very short, and we we would like to talk a lot. But I think in the short time that we have, I'd like to just take you through some of the solutions that we have, focusing on a key topic that Rashid mentioned, which is related to grid stability, grid monitoring, large power users, and how do we actually take this information that we get from AMI and smart meters, and what can we do with it? So just a quick slide to tell you about Kamstrup. Kamstrup has been in the industry for nearly 8 years. So we are focused a lot around utilities. We've been a leader in a lot of the sectors when it comes to analytics. And I'm not going to waste too much time on this slide. These are the core focus areas that we look into. And the two that I'm going to highlight is around the data management, data analytics, focusing on the electricity division. So what are we trying to achieve with data, right? I think in today's world, there's a lot of misconception that the more data you get, the better it is. I know there's been a few discussion points in many seminars around what do I do with the data that I get? And that's the crucial part. Kamstrup tries to utilize the data through analytics and machine learning to help a utility. So whether you've got a DSO, whether you've got a large power user, you need to provide them with key understanding factors around what is the data that they get in and how do I utilize it. So some of the business insights is grid capacity. We've seen it. Rashid has touched on it. We've experienced massive grid issues in South Africa through the load shedding periods. We're fortunately in a better space now, but we need to prevent this from coming up in a later part of our life. Another aspect that we need to look at is the performance. You know, when we talk about performance, how well are we actually operating our networks? Are our transformers operating correctly? Are our substations being monitored correctly and operating correctly? And are the right phases connected, in? So this is all around details that we need to look at from smart meters. Hence why smart meter rollouts are becoming a key topic in South Africa. And one of the other areas that we like to focus on is how do we reduce losses, whether it's technical or non-technical losses. What can we do to assist the utilities to find those losses? Now, when we look at the problem, there's a lot of issues that we see in our utilities, in our backyards, where if I have no information about where my meters are, it's a big problem. And inconsistencies between where the meter and asset registers say the data or say the meters are and what is actually being fed into the physical grid is a crucial topic that we need to address. And this is something that Kamstrup has pioneered and patented to assist utilities to understand what's happening on the network, which meters are connected to which transformer and substation. What we also have seen is, the way that the phases are connected are not correct, the way that the DSOs handle, the power factors. So related to what Rashid touched on, frequency monitoring, voltage stability, grid stability, it's all tied to what they give as best effort. And I think that the time is now where Eskom is driving this agenda in a correct direction, and we're going to see positive results. I think I have a lot of faith that we're going to see changes in the near future in South Africa, and it's all for the better. This is just a high level, discussion, what we've seen in Europe. And in terms of the green transition, we all like to talk about the green transition and aging infrastructure. So it can't all work together. We know we've got a lot of aging infrastructure. The utilities are implementing a lot of costs and funding to improve and renew the aging infrastructure that we have in South Africa. And we do have objectives to reach certain renewable goals. Eskom's agenda did mention that they want to reduce, their carbon footprint, working towards a greener transition. Fortunately, in South Africa, we're not seeing a big uptake in, the electrification utilizing different aspects, but we are seeing it slowly coming there where we want to grow the country, we want to industrialize the country, and that demand will continuously be something that we need to be thoughtful of and mindful of. I think the next slide, I just want to talk about the solutions because I can see the time is going actually pretty fast. So in terms of the solution, what are we actually trying to do? We're trying to prevent issues that we've seen in the past, whether it's overload, whether it's load imbalancing, and how do I create a sustainable system as a utility? When we're talking about grid performance, we're talking about a lot of aspects. And how does a utility actually create this universal approach for all the areas? We've got more than 10 or between 10 and 20 million meters in South Africa, and it's quite a large, project to maintain and observe as different entities are, relying on different solutions. So one aspect is when we're talking about a national AMI solution, there needs to be a universal approach that every single solution that goes out there meets certain criteria. And in terms of the monitoring of the solutions that we have, capacity levels are crucial. And, how do we actually say, if I've got so much capacity available, what can I provide back into the grid? Whether it be from, planning, whether it's from renewable energy, whether it's from solar plants, the battery system that Eskom is working on. There's a lot of improvements that we're going to be seeing in the network. So all of these are problems and solutions that we just touching on. This is just the tip of the iceberg. And once we go into the details, we've spent countless days discussing this with different DSOs in the world. I think the main thing is in terms of the solution that we have to focus on is what are the different types of topologies that we are trying to utilize within our power infrastructure? How do we manage our load analysis? And what are the solutions that we are utilizing to manage the load analysis? This could be related to a variety of things such as load management, load reduction, demand response, and then in terms of the switching between your capacities, how do you actually balance that out? So I've touched on a lot of the problem and the solution, but I went through that a bit fast just to give you a highlight of where we see this and what our patented solutions are. So we've got different solutions that, together with different providers in the world, have come to a solution that gives you important analytical information. Whether I'm using my brand, whether I'm using your brand, I need to be able to take this data in. And one of the solutions that we've got is called Power Intelligence. I need to be able to manage my flow of electricity. And this is basically from point A to point B to point C. Am I actually following the design methodology? When the engineers are designing a transformer that can handle a certain load, is it actually feeding the right amount of houses, and is it fed to the right houses? So in terms of the power flow, it utilizes patented technology again that we provide you with a lot of detailed insights that give you insights into the actual meter layout as well as the power flow that's happening from a transformer or a substation. In terms of the power quality monitoring, this is very important in terms of overvoltage and undervoltages, frequency instability, which we have seen that can damage a lot of large power users. Now, the core of what I'm focusing on is large power users, industrialized type of customers. And if there's instability there, you will see a lot of times that these customers will have issues when components or equipment gets damaged due to frequency imbalance, due to voltage imbalancing. So power quality monitoring is very crucial. And what we're looking at here, just give me a second, sorry. What we're looking at here is with power quality monitoring, you can basically reduce your operational costs, you can improve your customer experience, and you can optimize operations. So when I'm talking about this, it's focusing purely on cost reduction and optimized solutions, right? And I think that's more focused on one of the solutions. I think it's better if we talk just about a solution. So use cases are always important. We have to learn from each other. And when I'm talking about use cases, we've got a company for substation to the large power users was saving them approximately 50,000 euros. We can always share this information with everyone in terms of the actual use case as well as the case story. And one of the comments made by the manager there says, when we saw the proof of concept, they ran around with their hands in the air. And I thought, wow, that's an amazing, I have never seen anything like it before. And this is what we want to see in South Africa and lead the way in Africa. We have the right setup. Another one was Energy ICAS that we've done. They invested in all the analytic solutions. And what they did was, by doing this investment, they were able to recover the money within a year, and this added much more revenue to them. So one aspect that we do like to always share is customer engagement, because it's one thing trying to do all of this, but it's another thing making sure that the customers understand what they get in. Rashid touched on it, the shock factor, because if I just do something and I give you a higher bill and you don't understand it, it creates a lot of uncertainty with the customers, and you have a challenge when customers want to fight back. So customer engagement is very important to make them aware that this is what we are going to be doing. This is how we're going to help reduce issues within the grid. But the fact of revenue might increase. What I'm going to touch on just quickly before I end off, we do see that when I've got a grid and I'm investing a lot of money into the grid, you have different scenarios. One is where there's an assumption from the utility that I've got this down and I understand my loads and I understand that they're balanced, and they don't really need to upgrade their transformers. However, when you look at the reality, it's a different story. Right? You're looking at it from a perspective of what we see in our side. Are the transformers actually reaching their correct loads? And it's easy to pick where the issues are if you're monitoring these details. And this is purely related to large power users that are, utilizing a factory at 24 hours a day. You need to know, am I balancing my loads? Am I giving the right information to my DSO? Am I giving the right information in terms of load profiles? So all of this information is utilized through analytics. And I know we kind of throw around the term analytics, AI, and machine learning. However, what we've been doing is spending, a lot of time with data scientists and internal developers over the last 3 to 4 years to develop this technology with many partners in Europe, and we expanding this into Africa as well. And we can see that there's going to be benefits to this. And I think in terms of the conclusion, these are the main focus areas that we want to do. When we utilize, our grid optimization solution and the topology validation, we need to know what is our problem statement before we go in and throw a solution to any utility or any service provider. We need to know how do we help them first look into the details, look at the issue, look at the problem statement, and then look at the capacity monitoring. A lot of areas, the transformers are either overloaded or they're not sized correctly. And by just monitoring the substations and monitoring of your load balancing, you will be able to see a lot more than what you are seeing with the typical meters that you have. So to sum this up, what do you need? You need a smart meter. You need a full quadrant meter. You need a meter that can do power quality analysis. And then you bring the data into a smart solution. And I know there was a few questions around that as well, where smart systems are becoming the predominant factor. So as part of the architecture that you're going to be utilizing, you have to have it as milestone achievements that once you implement the solution, it's not a forward and backward, and I just put a meter in and expect it to do all of this. This is just an example of what we see on our system. It doesn't matter where or how the meters are installed, whether it's at a feeder station, a feeder transformer, or a substation. We can monitor a lot of information. What is the current flowing through it? Where is the meter in terms of GIS? How many meters are in that data sector? And think about looking at this picture. How can I take this and bring it into a South African context? We know that there's a lot of issues in our South African area. And I'll stop there. I think I'm on time. So if there's any questions.
Thank you, Mohsin. We just want to confirm, so you're done with the presentation?
Say that again.
Are you complete with your presentation?
Yeah, I think I'm on time.
Yeah,
right?
perfect. I think so. Thanks, Mohsin. Thank you for that.
Okay.
I think just obviously giving the insight to everyone again about data and load flow analysis. It's very important. It's a very important use case for the country, and I think the aim is to get the attendees to understand that, the wider value chain. So thank you, Mohsin, for that. I introduced Frank earlier before the break. Frank is from Meridian Economics, and I'm going to hand over to Frank to talk a little bit about wheeling, token wheeling, AMI in relation to token wheeling. So Frank, thank you again, and over to you.
Thanks, Rashid, and thank you for having me. Let me get the slides up, and if you can let me know if you can see, is that okay?
Yes, we can see it.
Okay, perfect. Thank you, Shannon. So yeah, thanks for having me on this webinar today. Wheeling has become probably one of the hottest topics in private power in the last, certainly in the last couple of months, but over the last couple of years, as people look to solve to how to get private or alternative to Eskom electricity through to customers. And Meridian Economics, who I'm collaborating with, has developed an alternative approach to wheeling that for now we're calling token wheeling. But perhaps to start with regular wheeling, for those that may not have come across this concept, it's really a way to account for private power being injected into the grid, being allocated to a customer who would like to buy that. And so there might normally be a PPA between the customer and the independent power producer for that power. And for example, if it's both are on the Eskom grid, then when that power hits the Eskom grid, the meters record that injected power. And of course, this is where the metering comes in from the metering side to be able to accurately know when and how that electricity went into the grid. And then ultimately, if it's an Eskom customer, Eskom would pass a credit for the value of that electricity to the customer. And the way that wheeling is normally conceptualized is almost tracking that power flow or that energy flow from the IPP, perhaps into Eskom, into a municipality, and to a customer, and then crediting all those bills as you go on the invoicing side in order to basically ultimately allocate the value of that energy to the customer. Now, of course, that is not actually how electricity flows. It's not the actual electron at one point that ends up at the customer. The whole grid is, as you will well know, almost like a dynamic pool. So wheeling is really just, it's almost a misnomer, because it's not like trucks with wheels that are moving goods from point A to point B. It's more, the grid, I guess, is more like a dam with lots of ins and outs. But traditional wheeling is one way to account for it. And we've also got a newer version that Eskom has launched called virtual wheeling, which is meant to enable the supply from one to many off-takers or many customers in municipalities. But all of these systems, whether it's conventional wheeling, which Eskom has implemented and one or two municipalities have implemented, like the city of Cape Town, they come with significant challenges. I mean, Eskom's own implementation in their own billing and invoicing system is not complete. It is quite a complex architecture to have to change in municipalities, that you need to change your supply agreements with your customers to allow this private supply of power. You need to change your supply agreements with Eskom if Eskom's wheeling that private power. You need to set up new tariffs. You need to change your billing system to be able to pass these credits on the invoice to your customers. And it all ends up being rather complicated and costly, and especially for small municipalities who might want to enable their customers to access private power, but comes with considerable complexity. It also makes it very difficult to get power to prepaid customers, because wheeling's more architected for postpaid customers. And most conventional wheeling today doesn't allow for LV or smaller customers to get that power. And then in the sort of Eskom to municipality space, we currently have the major issue that Eskom does not wish to allow the wheeling of private power into municipalities unless they are in good standing and remain in good standing. And so that's a significant risk for wheeling, whether it's conventional or virtual wheeling, which ultimately all of this complexity means that most municipalities found themselves in a position of finding it very difficult to implement wheeling. So when Meridian was working on this problem, they were looking to basically solve all these issues. Is there a way to make it simple? Is there a way that one can legally get around, I don't want to say get around, but legally make it simpler in terms of the requirements of the Electricity Regulation Act and the Municipal Finance Management Act, to deliver this private power whilst protecting the revenues of municipalities and Eskom, or perhaps even enhancing the revenues, helping with recovery, and unlock a larger market, especially in the municipalities where there are a lot of customers that currently can't access privately wheeled power. And so all of this was what went into the thinking around token wheeling. And really, it almost shouldn't be called wheeling. I like to talk about it almost as electricity settlement, it was a tokenized electricity settlement, because we reconceptualize the way that the power flows, rather than thinking about power flows, to think about how the money flows and see if we can end up in the same value transfer to all the parties through the loop, that's normally delivered by conventional virtual wheeling, but using a simpler method. And perhaps an example in a municipality will help explain this. So let's imagine we do have an IPP in the municipality who wants to sell power to a private customer or customers. Basically, they would then feed the power into the municipality as this would happen in any conventional space. That power would be metered, and obviously this is where the smart metering and AMI is required. But off the back of that injected power, the municipality would experience an avoided cost, in that they would have had to buy less power from Eskom on, say, the Muniflex tariff. And so what the municipality does is allow the token wheeling system to issue a credit note to that value to the IPP. So basically, and I'll show a worked example, but let's say 100 kilowatt hours were injected and the avoided cost was R1, then the credit note for that amount of power would be worth R100, and that would then be passed to the IPP. Then the municipality then carries on billing the customer exactly as they did before. They bill all the energy to the customer. So if the customer used 200 kilowatt hours at that point, then they would bill that full 200 kilowatt hours. Now, in conventional wheeling, you would argue, you would pass a credit to say, well, maybe 100 kilowatt hours of that 200 kilowatt hours came from the private entity, so I need to put a credit on your invoice. In our token wheeling system, we don't do that. We argue that the energy that the municipality is selling to the customer is all coming from the municipality, and therefore there's no need to change the supply agreements and there's no need to change the tariffs. Then the customer would have a PPA, or perhaps we call it a token purchase agreement, a TPA, with the IPP, where they would pay the IPP as they would under normal wheeling for the energy. But in return, they get that electronic credit note, or ECT, that electricity credit token that I spoke about, which has captured that avoided cost as a credit note or as a voucher. And this is where it's very different to regular wheeling. And then when they come to pay their bill with the municipality, they pay the bill with a credit note and the balance in cash. And this ultimately leaves the municipality revenue neutral in the whole transaction, but the customer has benefited from being able to acquire cleaner, more affordable electricity from the IPP. Maybe to show that in a worked example, if we have the municipality supplying the customer, say, at R2.40 a kilowatt hour, but is buying from Eskom at R1.63, and the IPP injects 100 kilowatt hours, then the avoided cost that the municipality experiences would be R163, because that's what they would, how much less their bill would need to be. Then if the customer's buying 200 kilowatt hours from the municipality bills them at the full tariff, and the customer would receive a regular bill for R480. But in return, the customer, say, maybe is buying or paying the IPP for the power at, say, R1 a kilowatt hour, but in return receives these electricity credit tokens, these credit notes, worth that avoided cost of R1.63 per unit times 100 units, worth R163. And so now when the customer comes to settle their bill with the municipality, they had a bill for R480. They settle it with the credit note that's worth R163, leaving the balance to be settled in cash. Now, what makes this a lot better for municipalities is that it only needs to be implemented on the settlement side with the credit notes, where already municipalities have significant settlement infrastructure to allow for third-party collections, whether it be from checkers or from a prepaid vendor or whoever it might be. It's completely simplifies the ability for the municipality to deliver that private power to the customer. Now, of course, in all of this, the metering has to be accurate and smart, and we need to be able to track exactly when that power was injected by the IPP into the grid so that we know accurately what the value of that power was once we do these transactions on the token wheeling platform. And I know we're a little bit time constrained, but I'll very quickly, that was the example in a municipality. It can also work if you introduce Eskom and a trader. Traders are obviously a little bit controversial, but you could have a trader buying the power from an IPP. Same procedures for the IPP injects the power into the Eskom grid. That's an avoided cost to Eskom. Eskom normally uses the WEPS less losses tariff, so it would be valued at that amount. The Eskom would authorize the issue of these credit tokens, these electricity credit tokens, or credit note or voucher, all the language that we use. The trader then gets these credit notes, and again, then Eskom sells all the power to the municipality as exactly as before. No need to change the billing or the use of system agreements between Eskom and the municipality. And then the municipality sells to the customer exactly as before. No change here either, except now that when the customer again, or at least the trader now passes to the customer those electricity credit tokens that the customer uses in settling part of their bill to the municipality, and then the municipality can settle with Eskom. And some of the smart things is that the customer might, included in this electricity credit token, can be the green attributes or the renewable energy certificates that capture the greenness that the customer can keep, and they can just use the component of the credit note to settle with the municipality. They could also, if they're not able to use the credit note, because let's say they have to do a December shutdown and they're not able to allocate the power, they could sell those credit notes to their neighbor who could use it to settle with the municipality. And ultimately, we envisioned a liquid secondary market in these credit notes, which actually is a whole way to enable trading, that the customer doesn't necessarily have to have a long-term contract with the trader. The customer could buy on short-term with the traders. And if there's a liquid market, these customers could be anywhere in any municipality or in Eskom, assuming those municipalities and Eskom support the token wheeling concept. I won't go through the Eskom worked example, but I mean, just very quickly, in summary, I spoke about traditional wheeling and virtual wheeling, where it's an accounting system around energy flows. In virtual wheeling, you put almost a virtual distributor in the middle that gets refunded, and then you have to take Eskom payment risk and payment delays. So there's some big challenges there. Whereas token wheeling is a complete reconceptualization of wheeling, as doing the settlement for electricity through these credit notes that are issued against the power. Yeah, as I've got there, it's a shift from energy to settlement, and it allows all the electricity supply agreement to remain unchanged. Obviously, the credit, the token wheeling platform needs to be able to be reliable, and secure, and obviously that all gets built on top of a sort of AMI architecture from the metering side, and that's pretty much how this fits together. And as I mentioned, it does allow a much simpler implementation of wheeling, or something that accomplishes the same thing as wheeling for municipalities. It can reduce credit risk. What I haven't spoken to is the ability to also escrow other values. So even the value of the Eskom power could possibly be escrowed in the system. And of course, if you do have a secondary market where anybody can buy these tokens, it improves the bankability for the IPP. Even prepaid vendors can buy it, because the prepaid vendor who's providing the electricity could offer their customers regular electricity or tokenized electricity, and they receive the tokens on behalf of the customer. And then when they settle with the municipality, the revenue they've collected, they pass the tokens and the balance of cash from the prepaid customers, yeah, almost like they already do. This also allows Eskom or the municipalities to keep their customer. They're still providing all of the energy. That's what we argue. And of course, the green attributes of the electricity, if it's green, can also be captured and shown. So that's really me quickly on token wheeling. I know it can be quite a lot to take in a quick bite like that. So very happy to answer questions or have a separate conversation offline. But thank you very much, Rashid and team, for having me.
Thank you, Frank. Much appreciated. I have been monitoring the Q&A chat box. I don't see anything specific at this stage. And what I'm going to probably do next is introduce the next session, which will be Pramod and Kalyan. But I'll give it a second or two to see if anything has come through. And probably what we can do, if we find we have some time towards the end after the presentation from Pramod and Kalyan, we'll just check to see if we can then take some live questions from the attendees on everything, from the AMI getting it right, through to what Mohsin presented, through to what yourself, Frank, have presented, and Pramod. So what I'm going to do next is maybe just do a quick introduction. I'll ask Pramod to, in the meantime, if you can just get your presentation up. The next section is really about, talking about cybersecurity and how it fits into AMI and how we typically leverage it to drive a digital transformation and its importance. The presenters are going to be Pramod. Pramod is an associate partner from Ernst & Young, based in the EY Mauritius office. Very fortunate to be there, and Pramod supports clients throughout Africa, India, and the Middle East, and has over 18 years of experience in information security domains. Then we also have Kalyan, who's a senior manager within the EY Mauritius office that has extensive experience within OT cybersecurity, because essentially a big component of an AMI solution or a digital solution within utilities is on the OT side, and OT stands for operational technology. So Pramod, let me hand over to you to continue with the presentation.
Thanks, Rashid. Thanks, Rashid and team, and thank you so much for having me. Team, my name is Pramod. I'm a cyber partner with EY based out of Mauritius. I have around 18 years of experience and all into cybersecurity. Right, I have engaged with the large-scale OT, IoT implementation projects and assessments as well. I've been an advisor to CISO and executive management for different clients that I've been working for. Right, I think a lot more have been covered by my colleagues, Rashid, Frank, the other colleague, while speaking about AMI and its functionality in depth. That has been so great to hear from them, giving their expert point of views. Right, I thought of covering the same thing to have the functionality explain, the architecture of AMI, the construct of it, but then it's already been covered. I'll continue from the security point of view, then Kalyan will take over going in depth. Right, so team, like any other IT system or like any other system, right, so AMI also have a critical infrastructure that needs to be protected. Right, so AMI has an infrastructure and the data and the application within it, a part of it ecosystem, as explained by the previous colleagues in the earlier sessions. Right, so cybersecurity has the same meaning and same inclination and the same importance for AMI as well. Though it's not a pure IT system, but it carries the same importance, the way we protect the IT systems and data, databases and applications, so on and so forth. Right, so let's look at what are the key components of AMI, right? I'll quickly touch base on those things. Smart meters are the one which comes with an operating system and the firmware, and physically it has to be protected, right? Smart meters are the devices that are installed at the end user locations, right? It has to be protected because it's part of the big ecosystem, but it's not controlled. It is not maintained in a controlled way, right? So smart meters is one system. Connect the network community, the network connectivity that establishes between the smart meters and the downstream system which process the data, that also needs to be properly protected. And we talk about head and devices. That's a core part of the whole AMI infrastructure. Again, it has its own importance of having the security rightly implemented, the right kind of technology control go into this setup. And we talk about backend utility systems, data management systems, and so on and so forth, right? So all those components are equally important because it contributes in the whole ecosystem of AMI, needs to be controlled. Let's talk about generic controls, what we generally think of IT, right? We talk about authentication, identity and access management, and authentication applies same here, because anybody who has access into head-end devices needs to be properly controlled and authenticated so that their identities are cross-verified, and the authorized users only have an access into the system where the actual processing of the data or translation of data happens, right? The communication channels, the way we handle the communication channels in IT network also applies here, right? The communication channels has to be secure enough. It has to be encapsulated so that the eavesdropping, people try to intercept into the traffic and understand and manipulate, that would not take place. No encryption kind of thing that needs to be put in place to ensure the end-to-end communication remains secure, right? For example, and the other things, if I talk about the devices that communicate with each other, right? Part of AMI, right? The smart meters are talking to head-end systems, right? It has to be ensured that the authentication between the devices also needs to be put in place. What essentially mean is it's not only the users that require to be authenticated, but the system itself. When they talk to each other, when they integrate with each other, systems also uniquely identified and authenticated further, right? And data at rest, right? So what does AMI really carries, right? It carries about the signal data, and it also carries the actual PII information, personally identifiable information that needs to be protected, right? Wherein we are talking the times of any personal information that is not handled properly would lead to $1 million, commissions from the regulator, right? The same applies to this particular sector also. Data protection in terms of customer has to be, the controls related to that has to be put in place so that the end customer data remains secure, right? So, and so on and so forth, right? All the things that we can possibly discuss in IT also really applicable for AMI as an industry as well, right? Most importantly, when we talk about the devices which are not well controlled, not part of your data center, right? We're talking about smart meters. Those are the things where it might undergo with the physical tampering or a firmware manipulation, right? Those are the devices where it comes with the firmware, what you call as an operating system, for example, to say, as a right analogy, right? Those can be tampered, and those will have misinterpretation in terms of signal and missed data being sent out, and there's an alteration of billing, and further impact and the damage could take place, right? So we are talking about those generic controls in terms of authorization, authentication, data security, device security itself, device authentication itself, communication channel protection. We are talking about TLS, SSL protocols being enforced among the system. Very much like IT also can be extended into this AMI infrastructure and so on and so forth, right? I would like to touch base on different types of attacks practically, but then in the interest of time, I may not be able to touch base on that. But just to give you some of the example that we have seen, right? In 2016, the attack about Ukraine is one strong example that we talk about how the industry has evolved, and the type of security controls that has come up after these kind of attacks have seen it, right, are good attacks that took place again, not against AMI but the whole industry as such, right. With that said, I will hand over this to Kalyan to take us further through the security matter. Kalyan, over to you.
Hey, thank you, Pramod, for setting the tone so well. So everyone, I'm audible clear and my screen is visible. Can someone confirm? Rashid?
Yes,
Perfect.
Kalyan.
Yes, Kalyan,
So,
you are audible.
thank you very much. So as we all know, the energy sector is going through a big modernization, possibly the biggest ever, driven by automation, IoT, and AI coming together. And the rapid growth of the smart grids and renewable systems are also creating a big change in this modernization. And at the center of this complete transformation is advanced metering infrastructure.
Sorry, Kalyan, sorry to interrupt. I think the slide presentation is not moving, so I don't know if you want to just see on
I'll
your
do it.
side.
I'll do it. Yeah, we haven't reached there yet. Okay. So as we have just learned, advanced metering infrastructure is not just smart meters. It's a connected ecosystem that delivers flexibility and efficiency. But as we modernize, cyber risk grows just as fast. Cybersecurity isn't just a network protection. It is about keeping the complete ecosystem of AMI reliable and resilient. And believe me, a strong cyber framework does not slow innovation, it fuels it. So, hello everyone, I'm Kalyan Sundar Mazumdar. A short introduction. I'm a senior manager, OT cybersecurity consulting at EY Africa. I bring over 20 years of experience in engineering and commissioning industrial control system. And my sole mission is cyber protect critical infrastructure and make it future ready. So today I'll share why cybersecurity is must and to be adopted as a culture, how AMI needs defense in depth, how strong cybersecurity strategy spanning across people, process, and technology becomes a tool to tackle next generation threats. So let's deep dive. I will. As you can see, the energy sector is facing a sharp rise in cyber threats. In fact, the attacks on the utilities is confirmed that it has jumped by 70% in just 1 year between 2023 and 2024. So why it's happening? The top three reasons in my mind is rapid digitization, IoT integration, and outdated legacy systems. We have many utilities still rely on old system without feature, basic security feature like even multi-factor authentication or even simple patch management. The cybersecurity is no longer just an IT issue. It's a strategic necessity. And to strengthen this complete ecosystem, we need strong pillars like, as Pramod mentioned, zero trust architecture, real-time threat detection and response, regulatory compliance and collaborations, and on top of it, workforce training and incident preparedness. So, in today's connected world, digital grids and AMI have changed how we produce and deliver electricity, bringing efficiency, sustainability, and real-time visibility. But as we rely more on these systems, our hackers are also getting smarter and more organized. Smart grids and power plants are now high value targets for them. And it is not just for the criminals, but also for state sponsored groups. This makes secure by design in AMI extremely critical. Every layer, from the field device to the communication device to control rooms to cloud platforms, must be protected. However, the challenge is these systems are highly interconnected, and one weak point, one unpatched SCADA device, one exposed remote access can trigger a chain reaction which can collapse the complete infrastructure. Cybersecurity in energy isn't about protecting technology. It's about protecting people, their trust, and the reliable power that keeps the world running. I hope you agree with me. So this is quite a slide and it has a lot of information which is scary. This timeline clearly shows how the energy and the utility sector has become one of the top targets for cyber attacks around the world. Let's continue the discussion what Pramod was mentioning that totally changed how the world looks at cyber risk in energy. Let's talk about the Ukraine power grid attack. So what happened? The story is in December, sometime in 2015, the hackers breached three regional electricity companies in Ukraine. They first entered the network through a simple phishing mail. They installed a remote access malware. It was called Black Energy. Once they were inside, they did nothing. They spent months and months quietly studying how the grid operated, mapping their control systems, operator routines, and the VPN connections between one office to their substation to another office. They learned everything. And then on one cold winter evening, they launched that. They took the remote control of the SCADA system and opened circuit breakers of more than 30 substations, led to cutting power of over 230,000 people. And they didn't stop there. They even disabled the backup system and wiped the servers with malware called Killdisk to slow down the recovery path. It was the first time in history a cyber attack physically shut down the electricity on a national scale. It literally showed the world that a keyboard and not a bomb took down country's critical infrastructure. The Ukraine incident became a turning point. Today, attacks on OT are focused. A single breach can stop the turbines, can shut down the substations, can cause blackouts, and even bigger economic losses. With IoT and automation getting inducted into more and more in this ecosystem, the attack surface expands. The line between cyber and the physical world is gone now. What used to be a computer problem now causes real world consequences. So we have gone through the global trend, and the trend clearly shows one clear truth. Cybersecurity in energy must evolve fast. Systems are now fully connected, which improves efficiency and visibility, but opens more doors for our attackers. Cyber attacks on critical infrastructure are used as weapons by criminals and even nation states. And to add to that, there is a big shortage of skilled cyber experts across the globe who can understand both IT and OT. Hence, many facilities are nowadays looking for an alternate measures like going towards AI-driven defense automation and many other things. So now, as we plan our future, it presents extraordinary opportunity to reimagine the complete cybersecurity picture and think it as a strategic accelerator for transformation across the complete energy value chain. The first one should be a robust governance and compliance standard. This is about having clear rules that everyone follows. The regulator follows, the operator follows, the partner follows, where we use the same framework across with a single target to create consistency and clear ownership. The second one should be transparency and accountability in the complete supply chain. And this is because the trust matters. There should be regular audits, regular checks, internal audits, external audits, and this kind of collaboration efforts make sure that every part of this complete end-to-end digital grid ecosystem follows the best security practices. The third one should be technical and operational compliance. Before any device or any system connects to this ecosystem or this grid, it should be tested and secured to its core. There are a lot of technologies available which can enable this. We have to enter those technology to make sure they are safe and they are secure. Such standard checks and automation helps us make sure everything works safely and fits together without adding any risk. Collectively, these dimensions shift cybersecurity from reactive defense to a proactive instrument of resilience, positioning it as both a shield and a catalyst for innovation. Once we implement everything together, we'll be more confident to take the next step towards the digitalization because we are sure what we have built is super secure. Now let's try to look into all these opportunities and understand them a little better. So I'll spend a moment. Oh yeah, there's the first one. So the first one, what I mentioned is the governance piece. We need one unified framework for all energy players, government players, private or the regulators, harmonized policies across, clear directives with strong enforcement which will build accountability and trust. This isn't just a policy. It needs to be developed and adopted like a culture. The second one shall be transparency. The energy supply chain is huge, and with one mistake, a vendor can put the complete grid at risk. We have to conduct regular audits, regular checks, internal audits, external audits, red teaming, blue team. Everything has to be done very perfectly and in a proper way of policy. Use smart tools, even use AI for policy checks. This will help to ensure everyone meets the same security standards. The bottom line is transparency builds trust and trust keeps the power flowing. Now the third one will be the technical compliance. Every device in the system should be cyber secure by design and verified before joining the grid. It should be a process and it should be followed diligently without any bypass. This is the only way how we bridge innovation and trust. Now, when we look all these three opportunities together, the governance, the transparency, and the technical compliance, one clear message stands out. Cybersecurity is the center of digital transformation in the energy sector. In today's energy landscape, security is no longer just a checklist. It is the currency of trust. So as I conclude, I want to leave you with some clear call to action, a simple roadmap to strengthen the digital future of the energy sector. First one, invest on resilience. It bears fruits which are very sweet. And yes, you have to. There is no bypass to that. Adopt zero trust and predictive monitoring. Train your workforce. It is very, very, very important. They are the first line of defense. Design your system for future. You need to anticipate the change and don't be just reactive to the changes. And the last one, strengthen the partnerships. Industry, government, academia, everyone need to come together, work together, come to a very strong cybersecurity solution for this complete ecosystem. So here I would like to end with a very simple message. Cybersecurity is not a barrier to progress. It is the foundation that keeps innovation standing. In the world where energy flows through data as much as it flows through wires, security is what actually keeps the lights on. So thank you. And I move to Shannon.
Thanks, Kalyan. I'll hand over to Rashid to start the Q&A.
Thank you, Shannon, and Kalyan. Thank you for that presentation. Cyber is very important, and when one, as I mentioned before, thinks to their strategies, as Kalyan and Pramod have mentioned, this is something not to underestimate, and to upfront make sure you've got the secure by design thinking, the frameworks. I am watching the questions and answers, as well as the presentation or the chat box. I don't see any questions at this stage, but we'll give it another minute. Perfect. Comments? Thank you, Alexandra. Yes, do follow the team on LinkedIn as well. I think maybe Shannon, I don't see any questions at this stage. I do want to say, I'm going to probably hand over to you to sort of do a closing, but obviously you've been introduced to the various speakers. So any of the attendees or participants here today, I guess if you want to reach out to any of us as speakers to unpack any items, we're more than willing to have those discussions. I think our contact details will come shortly, and they can also be obtained through Shannon and the team. I see there's a question from Connie. Let me just read out. You can also answer this one offline. The German FDE FNN's vision, the energy system in 2030 has certain cyber security infrastructure. Can you comment on this and how we can learn or transplant this into South Africa. So Connie Milan, the question from Corny. Kalyan or Pramod, I don't know if you want to answer that. And also, as you're thinking through and about to answer, remember, if there's any other questions to Frank, if there's any questions to Mohsin, if there's any questions to myself, please add them now. Now is your opportunity. So Kalyan, over to you if you want to answer that, or if not, if you want to answer that after, best you respond.
Yep. So, sorry, Rashid, I missed the question. I tried to find the question here, but I could not. What was the question? Can you please come again?
Let me just repeat it for you, Pramod. So
Yep.
the question is, the German FDEs, FNNs, the vision, the energy system in 2030 has certain cybersecurity infrastructure.
Mhm.
Can you comment on this, and how can we transplant this into South Africa?
I think that's more about the governing bodies call than us, right? So if German VDE, right, they have a vision of energy system by 2030, right? I'm sure the way the governments are working and the authorities are working to bring in the best in class controls and the frameworks that needs to be enforced, within the OT, IoT, all the systems together. I think it should be very sooner than later, right? The whole focus is shifted now. At least the seriousness about the security has really grown from the years to year, and I'm sure this would be sooner as a vision that would be imbibed into the control frameworks.
Absolutely, 100% second to that. German VDE. But yes, before developing, they had a very strong foundation on which this vision has been developed. It can be very well adopted to the South African market, but we have some groundwork to be done before in order to reach to that maturity. But yes, it is very much possible.
Thank you, Kalyan and Pramod. I think I think also if there's a response that we need to give after, we can definitely do that. I see there's a second question specifically to me about the performance of the Sigfox network in South Africa. And maybe the way to respond to this is, remember, I can't directly respond about the performance of a particular network, whether it be a Vodacom or an MTN or a Telkom or a Sigfox, right? There are various providers that provide networks. Similarly, there are various meter providers like Camstrip, Landis+Gyr, Gear, etc. It wouldn't be appropriate for me to provide an opinion on any technology. But what I can say is that technology, right? Any technology, and if we talk meter or if we talk communications network, what I can advise is that what network you use is dependent on that use case that you apply. And a device, an IoT device or a metering device, etc., right? It depends how often you're going to obtain data or how often it's going to send data to you. And it depends to what extent you are going to want to control that device or not. In the case of a smart meter, a prepaid smart meter, you'd want to connect or disconnect the meter, etc., remotely, etc., etc. So this the Sigfox network and how it performs, or an MTN network or a Vodacom network, is dependent on that use case. It's dependent on the geography, it's dependent on the density. It depends on the area. Some networks are good for how they penetrate through buildings. Other networks need line of sight, and all the technologies are created differently. The best way is, with whether it be Sigfox or a cellular provider, they're typically very open to engage with clients to explain their technology, to understand your use case, to run tests, to run pilots. So the best thing to do with any network, one cannot look at a Sigfox network in Gauteng versus Western Cape. It's dependent on the base stations they have, etc., etc. So always in any of your solutions, you will have to do some pilot testing. You will have to engage the provider to understand how their networks are rolled out, how they have coverage, and a lot of this is actually publicly available. If you go to the various network providers' websites, they do provide you coverage maps at certain levels, etc. So yes, I think that's sort of the response there. It depends, and there's an approach to be followed. So I hope that sort of answers the question there. I see there were some questions from Connie to Frank on token wheeling. I see there's a few on token wheeling, but I see, Frank, you have answered all of those in the Q&A chat box. I don't know if there's anything that you want to elaborate on further that you couldn't answer in the chat box that you're seeing as a theme from all the questions that you maybe want to answer.
Thanks, Rashid. I think it's all been answered in the chat. Nothing additional to add.
Okay. So then I think, Shannon, I think many of the questions have been answered to the attendees.
I think,
Yeah.
Rashid,
So
I'd just
Shannon?
like to perhaps go back to Zayden. He did ask a question earlier about battery energy storage. He had an additional follow-up there, and he just wanted to know, will it be better for the BESS to charge from the grid or from solar or wind? Perhaps somebody would be able to respond to that one.
I'll see if any of the panelists can. It's actually quite a technical question.
I'm happy to, Rashid.
Yeah, go ahead, Frank.
Yeah, so I think that's it's a sort of a it depends answer, because batteries can do so much or add so much value to the grid depending on where they're located. So there certainly is a case to co-locate batteries with generation in order to smooth out that generation at point of source, especially if you want to deal with some of the variability of solar or wind. But then, batteries deployed, by themselves at substations can then help manage peak demand at that substation, and load variability, and voltage spikes or voltage issues in real time. So I think a lot of it really depends on the use case, because then you can put a battery behind the meter as well, and then it can do tariff arbitrage, it can do backup power. So I think it really depends on the use case or use cases that you want to use the battery for, at the point where the battery is going to be deployed, whether it's with generation or not. There's certainly value for all of those cases, depending on what's required.
Great, thank you, Frank. Yeah, Rashid, I think just in the interest of time, I think any other questions that have come through, I'm happy to send through to any of our panelists afterwards for them to correspond with you after the session and offline. So if anybody would like to say any final remarks before we close off, now's your chance. All good?
None from me.
All right.
I'm good.
All right. Thank you very much then. And that does bring us to the end of the session. I would like to thank all our panelists for their insights and to everyone who joined us for the first session in our two-part series on the South African-German Energy Partnerships Report on opportunities for digitalization in the South African energy sector. A big thank you to all of you who engaged through the Q&A and the chat. Your participation helps make these conversations dynamic and meaningful. As a reminder, today's session has been recorded and is also available on YouTube, so you'll be able to revisit the discussion or share it with colleagues and peers. You'll also receive a copy of the slide deck at the end of the session. On behalf of our team and the panelists, thank you again for spending your time with us. We look forward to continuing the conversation in the second session, taking place on Wednesday, 29 October at 10 a.m. South African time. The link to register for the second webinar was shared in the chat. If you have any further questions or would like to continue the conversation, feel free to reach out to us via email at shannon@creamermedia.co.za. And with that, I'd like to bid you all farewell. Stay safe, stay well, and goodbye for now.